Hello, hi everyone. Good afternoon. So welcome to Board Brahmastra. कौन कौन है आज यहाँ पे? कौन कौन लाइव मुझे देख रहा है? Say hi or say something so that I'll know you're present. Okay? So today we are going to learn very important topic. I'll tell you why. Because at the end I'll show you or will do two previous year questions. So that one is like 2 years back and another question came 3 years back. So those two questions, one is 4-mark question, another is 5-mark questions, and we'll solve that at the end. So that is the reason I'm telling you this is very important topic. Combination of resistances. So we'll quickly revise what we have learned till now. In the last class, this is about me. If anyone is new, I have done PhD in physics from NUS Singapore, BSMS degree from IISA Pune, as a ranker in IIT Advanced. Okay, so good afternoon, Dhyan, PLP, Ankur, No Brainer, Manuara, Prince, Karan, Rishika, and Farooq. Good afternoon all. Let's begin. So there is a Ohm's law. This statement tells you the Ohm's law. So V is equal to IR. What is V? V is the potential difference. So what is this? This electrical bulb. So it can be any electrical device. So all electrical devices will have certain resistance. Correct? So this, let's suppose if you close the switch, so current will pass through it. So if you measure the potential difference across this resistance, that is our V. And this potential difference will be equal to the current which is passing through this resistance multiplied by the resistance value. There is a Ohm's law. And how will you measure the current? To measure the current we need ammeter to measure the current. How will you measure the potential difference? Using the voltmeter. Potential difference or the voltmeter is always arranged in parallel with the resistor, and the ammeter will be always in series. Correct? And you see the symbols? This positive should be connected to the positive of the battery, and this positive here should be connected to the positive of the battery. So then only you will get the correct sign. Otherwise you might get the opposite sign, like the incorrect sign. So now you can arrange the resistors in two ways. One of them is in series. You see this R1, R2, R3, all three of them, they are arranged in series. Can you see? So when you arrange the resistances in series, what is common? You see the current which is flowing through it. You see here, the current which is flowing through all three of them is same. Current will be constant. Will the potential difference be same? No. Potential difference may not be same. If the values of R1, R2 and R3, if they are equal, then potential difference would be equal. Otherwise, it should not be equal. It cannot be equal. Okay? Hardest lesson? No. This is very easy, very simple. Just pay attention. Rihan, just pay attention. You will able to solve all the questions from this chapter. So now the resistances, you see these are in parallel. How will you tell if the resistances are arranged in parallel? So when the resistances are in parallel, the current values will be different. But what is constant here? It is the potential. Voltage will be constant. So how to determine whether the resistors arranged in parallel or series? If voltage is constant, that means they are in parallel. And if current passing through them is constant, then they are in series. Just remember these two. Current is constant, same current passing through it. So these are in series. If there is a same potential difference between all three of them, same potential difference, that means they are arranged in parallel. Okay, so now, solve this question. In which of the following case through all the resistors current is same? Is it series combination or series connection, parallel connection, both, or none of these? Difference between voltage and, there is no difference between voltage and potential difference. Okay, after this question I'll tell you the difference. So in which of the following case current through all the resistors is same? Tell me the answer. Current is same, basic. It should be series. In series current is constant. In parallel potential difference is constant. So now somebody asked me the difference between voltage and potential difference. So what is potential difference? Okay, there is a empty space here. I'll use this space. So if this is a resistance value, correct? If the potential at this point is, let's suppose V1, or this point A and this point B. So VA is, let's say, plus 5 volt and VB is, let's say, plus 10 volt. So these are the potential at A, potential at B. So the potential difference, you can write it as change in potential between these 2 points. There is a potential difference will be equal to plus 5 volt. 10 minus 5 will be 5 volts. Correct? There is a potential difference. And whenever I say voltage, that only means let's one of them terminal, I assume it to be 0 volt. So whichever, I'll redraw this circuit. So whichever terminal, these are the 2 terminals or 2 points, point A and this point B. So whichever is at a lower potential, this one is plus 5 is lower than 10, correct? So this one I assume it to be 0 volt. Whichever at a lower potential, I'll consider to be 0 volt. So the other one would be at plus 5 volt. So this is a voltage. Voltage is same as the potential difference, just that we compare with respect to the ground. Understood now? Rihan? Okay, so you see here, I'll erase this. For this question, the current through the series is same. Current through the parallel, it will split. So it is not same. So it is correct option is option number A or 1. So second one, in the circuit diagram, which of the following is true? I'll give you the hint. There is a circuit diagram. So which of the following is true? It is multiple correct. So choose all the correct options. Ammeter in series with the resistor. You see, if let's say there is no voltmeter, there is only ammeter. So the same current will pass, whatever current is passing through the ammeter, same current will pass through the resistor, correct? If you have connected only the ammeter. So ammeter connected in series, this one is correct. Ammeter in parallel, no, we never connect ammeter in parallel. Next one, voltmeter in series. We do not connect voltmeter in series. We connect the voltmeter in parallel. So 1 and 4, these are the correct options. Great. Now, if you have the series combination, you see R1, R2, R3, they are arranged in series. So the total voltage, it is the total voltage provided by the battery will split. So it is the V1 across R1, V2 across R2 and V3 across R3. So the total voltage will get divided in V1, V2 and V3. And what is this? This is the series resistance or the equivalent resistance for this combination or the net resistance. You can use different words, effective resistance, equivalent resistance or the net resistance for the series combination. It will be given by just addition R1, R2 and R3. You don't have to remember the derivation, just remember this formula. This is more important than the derivation. So I'll skip the derivation. We'll focus on the formula and we'll learn how to use this. So for example, here R1 and this R2, they are in series, correct? So the equivalent resistance is R1 is 6 plus R2 is 4. So 6 plus 4 will give you 10 ohms. This is the equivalent resistance. So between the point A and point B, the equivalent resistance is 10 ohms. Pranam, Yugal, Kishore. So now solve these questions. Two equal resistors. I'll draw it. Two equal resistors. Both of them value is 4 ohms. 4 ohms and 4 ohms. They are arranged in series. So what is the effective or equivalent resistance of their combination? There can be different words: effective resistance, equivalent resistance, net resistance, total resistance. You can use different words. All of these mean same. When you arrange them in series, you just add. So it is 4 plus 4, that would be 8. So the answer would be 8 ohms. Nice, you are able to solve, great. So now let's understand the second combination. If let's say R1, R2, R3, they are arranged now in parallel. You see, they are arranged in parallel. So there is a voltmeter. If you put a voltmeter, you see this terminal X and this one Y. This is also called as terminal, or you just say point X and point Y, junction, where these three resistances, they are connected, correct? This is a common point X and Y. So when you measure the potential or potential difference using the voltmeter across R1, R2 and R3, the potential difference will be constant. So how do you know if the resistors are in parallel? The potential difference should be constant. Okay. So now what will happen to the current? The total current which is supplied by the battery will split. So let's suppose I1 will pass through R1, I2 pass through R2 and I3 passing through R3. So the total current will split into I1 plus I2 plus I3, and the effective or equivalent resistance is given by this equation. So take the reciprocal of R1, reciprocal of R2, reciprocal of R3 and add 3 of them. So that's how you get 1 by Rp. So I'll give you one example here. So these two resistances, 4 ohm and 4 ohm, they are arranged in parallel. So 1 by Rp should be equal to 1 by R1. So now one of them is R1. So 1 by 4 plus another is R2. So it is again 1 by 4. So the denominator is same, 4. LCM would be 4. So it is 1 plus 1, which is 2 by 4, which is 1 by 2. But what is this 1 by 2? It is 1 by Rp, correct? So here Rp would be 2 ohms. So this is the equivalent resistance for the parallel combination, correct? 2 ohms. Okay, there is the same question actually. So two equal resistors, they are arranged in parallel, same 4 and 4, 4 and 4 arranged in parallel. Just now we solved this question. What is the effective or the equivalent resistance for this combination? And it is 2 ohms. How will you solve? Using the parallel formula, this formula. 1 by Rp is 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So now solve this. So there are some numericals we are going to solve. For every numerical, I'll give you 30 seconds. I cannot give you a lot of time. Try to solve. Salam. Shahid. Hi Shahid. Good afternoon. So okay, here there is a point A and point B. So we want to find out the total resistance value total resistance value between A and B. So now just try to understand this figure. So here, let's suppose the total current I is flowing through it. So what will happen? Some current, let's say I1, is passing through the 6 ohm resistance. So whatever is left, which is I, total I minus I1, will pass through these two. So is it equal? Is I1 equal to I minus I1? No, it doesn't have to be, correct? So these two and this one, they are not in series, that we can tell. So now let's check some points here. Let's consider this point here and this point here. This point X and point Y. These are the common points. Point X and point Y. These are common points or common terminals between this 6 ohm and between these two. Correct? So these two are in parallel with this 6 ohm. So they are in parallel effectively. Correct? But now before we solve for the parallel, understand these two resistances. Here the current, this current is the same current. Same current will flow through these 6 ohm resistances. If the same current is flowing through them, that means these two are in series. So we have to calculate our series first. So I'll redraw this diagram. Let's redraw this point A. So here, instead of these two, I'll write R series. And then we have 6 ohms, this point B. Correct? There is a equivalent circuit diagram. So we need to calculate RS. So how will you calculate RS? So RS will be equal to, there are 6 plus 6. So it is 6 plus 6, which is equal to 12 ohms. So R series is how much? 12 ohms. So now this 12 and 6, they are easily in parallel, correct? You agree? This 12 and this 6 ohms, they are in parallel. So if these two are in parallel, okay, I'll change the color. If these two are in parallel, so we need to use the parallel formula. So RP would be 1 by RP is 1 by R1, that is 1 by 12 plus 1 by 6. Yes? So now LCM of 12 and 6 is 12. So LCM is 12. So what will be in the numerator? It is 1 plus 2, which is 3 by 12. But what is this 1 by RP? So 1 by RP is 3 by 12, which is equal to 1 by 4. This is again 1 by RP. So from here RP would be 4 ohms. So what is this? This is the effective resistance between A and B. So the correct answer here should be 4 ohms. There is a equivalent or the total resistance value between point A and point B. Okay? You are from Pakistan? Okay, nice. Yeah, education is free to everyone over the internet. So solve this. Okay, I'll explain the question. So there are 3 resistances, 2 ohms, 3 ohms and 6 ohms. Correct? You have to arrange them such that the total resistance value can either be 4 ohms or 1 ohm. So let's do the simple arrangement. Let's arrange all in, so all in series. If you arrange all of them in series, so what are these? 2, 3 and 6. 2, 3, 6. So R series will be how much? 2 plus 3 plus 6, which is 2 plus 3 plus 6. That will come out to be 11 ohms. Correct? When you arrange all of them in series, I will write this as case number 1. All of them in series, the effective resistance is 11. Do we need this? No. This combination is not required. Okay? This one is not required. So let's arrange all parallel. There is a second arrangement. So it is all in parallel. So look at this arrangement. So this is 2, 3 and 6, all of them in parallel. Now calculate the effective resistance for this combination. So 1 by Rp should be equal to 1 by 2 plus 1 by 3 plus 1 by 6. So what is the LCM of 2, 3 and 6? LCM would be 6. Correct? So 2 into 3 plus 3 into 2 plus 1. So 3 plus 2 is 5 plus 1 is 6. So it is 6 divided by 6, which is just 1. 1 by Rp is 1. That means Rp is equal to 1 ohm. So now we got this one. If you arrange all of them in parallel, we get this combination. The effective resistance, the total resistance value would be 1 ohm. Got it? So now, how will you arrange them so that the net resistance value should be, or the equivalent resistance would be 4 ohms. So I'll tell you a trick. When you arrange them in parallel, you see the effective resistance reduces. When you arrange them in series, the effective resistance increases. Correct? So 11 ohm is greater than 2, 3 and 6. Here 1 ohm is less than 2, 3 and 6. So parallel reduces the resistance and series increase the resistance. So now you want 4 ohms, correct? So this 6 ohm resistance should be in parallel with something. So we can do something like this. There is one resistance, 6, there is 6, and let's say there is 3 ohms, there is 2. I'm just giving you random values. So there is a trial and error type question. You have to do different kinds of arrangement to calculate the exact values. So for this combination, these two, 6 and 3, here we have the common point. So 6 and 3, they are in parallel. So first compute the parallel resistance value. So I can redraw this. This is 2 ohms and this is Rp. So we want to calculate this Rp value. So what will be Rp? 1 by Rp is 1 by 6 plus 1 by 3. Again the LCM of 6 and 3 is 6. So LCM is 6, it is 1 plus 3 into 2. So there is 2 plus 1, which is 3 by 6, which is 1 by 2. There is 1 by Rp, correct? So Rp value would be 2 ohms. Rp value is 2 ohms. So now let's go back. Here this Rp value is how much? 2 ohms. Just now we have calculated it. So what is the net resistance or the total resistance? Total resistance value would be 2 plus 2, which is 2 plus 2. These two are again in series. If the resistances are in series, you just add. So it is 4 ohms. So we got this. To get the total resistance as 4 ohms, we need to have this kind of arrangement of the resistances. Understood how to arrange them? Okay, great. So now let's go to the next question. Read this question. So find the equivalent resistance for series and parallel combination of 1 and 1000. So I'll draw the resistances first in series. So this is the 1 and 1000. 1 ohm and 1000 ohm. They are in series. Correct? And another is parallel combination. So we have 1 ohm and 1000 ohms value. Correct? So we need to calculate the equivalent resistance. For series, it is very easy. You can calculate within minutes now. Within seconds, I mean. So R series would be just 1 plus 1000. correct? So R series would be 1001 ohms. And now they are in parallel. So 1 by Rp would be 1 by 1 plus 1 by 1000. Yes? So the LCM of 1 and 1000 is 1000. So I'll write the LCM, which is 1000. So in the numerator it would be 1000 plus 1. That is 1001 divided by 1000. But this is 1 by Rp. Correct? So what is Rp value? Rp value is 1000 divided by 1001, which comes out to be approximately 0.999. Okay, so I'll tell you now why I have chose this question, to understand you certain thing. So these two, just now look here, these two values 1 ohm and 1000 ohm, these are the values of the resistances. And you see here, the series resistance will always be greater than the individual resistances, and the parallel resistance, which is this one, will always be less than all the individual resistances. Okay, just remember this will always be true. Series always greater than the individual resistances, parallel always less than the individual resistances. Okay, so now which combination has a practical use? Which one you should use in practical? You see here, when you arrange them in series, if one of them is broken, you see here, this one is broken, so even this other bulb, which is good condition, still you cannot use this, correct? But when you arrange them in parallel, one of them is not working, but still other one you can use it. So parallel combination has lot of practical applications, and I'll tell you all the different applications. One is it maintains constant voltage. So when the current comes to our houses, it is maintained at a constant voltage. So all the devices that we use can be maintained at a constant voltage in parallel. Then the second one, each component can draw equivalent current. So each component can draw the required current from the circuit. If let's say there is a AC might need, or the heater might need larger current, or if there is a, let's say, light bulb may not require that much current. We'll learn that how much current is required in the heating effect, that is on Saturday. Do join us, okay? And the third one, if any component fails, still the circuit works. Circuit doesn't have to break. Fourth one, the total resistance is lower. The equivalent resistance in parallel combination is lower than individual resistances. All these are advantages of parallel combination over the series combination. Okay, so now let's solve a couple of more questions, then we'll solve the previous year questions. Solve this fast. I'll explain the question. 4 resistors, 100 ohm each. They are connected in series. So let's draw it. 4 resistances connected in series, and potential difference of 100 volt. That means there is a battery which supply the potential of 100 volt. These are all 100, 100, 100 and 100. I'll not write the ohm symbol because it would be too clumsy otherwise. So what if we have to find out amount of current in the circuit? What is the current which is flowing through this circuit? So how will you solve? First, these 4 are in series. So we can calculate the series value. So for this, we can draw the simpler circuit diagram. So it is something like this. These are series and there is a battery which is 100 volts, R series. So we have to calculate the current. So what is R series? All of them in series, so just add them. So it is 100 plus 100 plus 100 plus 100. So that will come out to be 400 ohms. So there is a series resistance value, correct? So now instead of R series, I'll write this as 400 ohms. Okay, so now what we use is, we use the Ohm's law, our favorite. So current will be equal to voltage divided by R series. Yes, what is the potential difference of the voltage? It is 100 volts divided by the series resistance value, which is 400 ohms. So what is the current value? So the current value is 1 by 4, which is 0.25 amperes. Understood? Easy? Just calculate the effective resistance. There is a series combination, so I have calculated the effective resistance for the series combination, and then use the Ohm's law to calculate the current in the circuit. Okay, let's go to the next question. Okay, solve this. If anyone has doubts, you can pause the video and try to understand. Okay, try to understand what is the which step you have missed. Yes, correct, you are first. Nice. Okay, so there are three resistors, R1, R2, R3. They are arranged in, connected to a battery of 12 volt. They are arranged in parallel. This battery is 12 volts. Correct? So what we have to find out? Current through each resistance. So we have to calculate the current I1, I2, I3. Current through each of them. Then the total current in the circuit. What is this total current? And total circuit resistance. So let's do it one by one. So if this is a 12 volt supplied by the battery, if I measure the potential difference across these three resistances, it will come out to be 12 volt. Yes, because there is only this resistance. All the other are wire, and these connecting wires, they have negligible resistance, almost zero. So you can just ignore all the potential will appear only across these resistances. So now for each one of them, potential difference is 12 volt. So how will you calculate I1, I2 and I3? So we will have to use Ohm's law. So what is Ohm's law? Ohm's law says that current is equal to potential difference divided by resistance. We use this Ohm's law to calculate I1, I2 and I3. So I1 will be equal to V is constant, 12 volt divided by R1. What is R1? R1 is 5. Correct? So this is divided by 5 ohms. So this will come out to be how much? 12 divided by 5 is 2.4 amperes. Correct? Then I2, how will you calculate I2? I2 will be this voltage divided by R2. R2 is our 10 ohms. So I2 is 12 volt divided by 10 ohms. Yes, so that would be 1.2 amperes. And what will be I3? I3 is 12 volt divided by R3, which is 30 ohms. 12 divided by 30 ohms. So it will come out to be how much? So 1.2 divided by 3, which is 0.4 amperes. So these are the three currents. You see here, the current which is flowing through the parallel may be different because the resistance values is different. So now we have calculated current through each of them. So the next one is total current. This total current I. So we know the total current I will be equal to I1 plus I2 plus I3. So what is I1, I2 and I3? I1 is 2.4, I2 is 1.2 and I3 is 0.4. So the total current value will be, this 4 plus 4 is 8 plus 2 is 0, 10. So 1 plus 1 plus 2 is 4. So total current is 4 amperes. So the total current in the circuit is 4 amperes. Correct? So now I'll redraw this diagram. So here I'll just, instead of these 3 resistances which are connected across 12 volt battery, there is R1, R2 and R3. So instead of this, we'll draw the equivalent diagram. So this is RP, correct? There is a total voltage which is 12 volt, and the current we found out to be, how much is this total current? I. So the total current I is 4 amperes, correct? From this here, total current I is 4 ampere. So now we want to calculate total circuit resistance. So we want to calculate RP. I'll tell you another method to calculate RP. So again, for this circuit, you can use the Ohm's law. So RP can also be written as total voltage or potential difference divided by current. Total voltage divided by total current. What is the total voltage? 12 volt divided by total current, which is 4 amperes. And RP will come out to be 3 ohms. So this is another method to calculate the parallel resistance. You want to compare with our normal method for this. So 1 by RP is 1 by R1. I'm just comparing, okay? If we get the same value, 1 by R2 plus 1 by R3. Let's just substitute the values. So what are the 3 values here? 5, 10 and 30. So substitute this, 1 by 5 plus 1 by 10 plus 1 by 30. So what is the LCM of 5, 10 and 30? So it is 1 by RP, LCM is 30. So 5 into 6 is 30 plus 3 times 10. So 3 plus 1. So what is 6 plus 3? 9 plus 1 is 10. 10 divided by 30. So this is 1 by RP, correct? You can cancel these zeros. So 1 by RP is 1 by 3. So from here, RP will be 3 ohms. You compare this. You can use any method, still you should get the same answer. Okay, so we have solved this one, solved this one, solved this one. Okay, so let's now go to the 2 previous year questions. If anyone has confusion here, stop the video, pause the video and try to understand. Watch it multiple times, okay? So now this is a 4-mark question which came like 2 years back. You see there is a circuit diagram, and what we have to calculate? The total resistance of this circuit and find the total current in the circuit. So I'll tell you why this is a 4-mark question. Because you see, is this R1 in series to R2? Is the R1 in series to R2? No. Is R1 in parallel with R2? Again, answer is no. So like it is very confusing. If you see this question for the first time, you might feel, okay, I don't know how to start or from where to start. So I'll tell you a hint. First find which are directly in series or directly in parallel. So let's erase everything. I'll need a lot of space here. You see this R3 and this R4. If let's say current of I is passing through R3, the same current will pass, sorry, not I1, same current will pass through R4. So what does it tell you? The R3 and R4, they are in series. Yes? So I can redraw this as an equivalent circuit. Everything else, you keep it as it is and redraw it. So how do you redraw? There is a battery which is 24 volts. Then we have R1. This is R1. Then here we have R2, and out of these two we get R series. Correct? R series is nothing but R3 plus R4. Correct? These two are in series. That's why I have written R series. Everything else as it is. Battery 24 volts as it is. I'll just write V. Okay, so now R3 and R4 in series. Can you calculate what is RS? So the RS value would be 6 plus 4. It is 6 plus 4. R3 plus R4. Correct? So that would be 10 ohms. Yes? So now this R2 is how much? I'll erase this numbers, erase these names, and I'll write down the values. Or we can do in better way. R1 is 7 ohms, this R2 is 10 ohms, and this R series would be 10 ohms, and the battery is 24 volts. So now here consider these 2 points, point X and point Y. So this point X and Y is common for R2 and R series. Correct? So if I measure the potential difference across R2 or R series, the potential difference will be same across R2 and R series. So what does it tell you? R2 and R series must be in parallel. Do you agree? The potential difference between R2 and R series is same. That is the reason these two must be in parallel. So let's draw the equivalent circuit for this. Everything else I'll keep as it is. So here we have the battery which is 24 volts. Then we have R1 which is 7 ohms. Then for these two, R2 and RS, I'll draw just RP. There is an equivalent resistance for R2 and RS. So let's solve it in the next page. So 1 by RP is 1 by R2 plus 1 by RS. And what is the value of R2? R2 is 10 ohm, RS is 10 ohms. So 1 by RP will be 1 by 10 plus 1 by 10, which is just 2 by 10, which is 1 by 5. But what is this? 1 by RP, correct? So RP value is 5 ohms. Just take the inverse of this. So now this RP we have calculated to be 5 ohms. So now our life is much easier. You see here the current which is flowing through this. Let's suppose there is a total current. The same total current will flow through R1, and again the same total current will flow through RP. So now this R1 and RP, they are in series because the same current is flowing through it. Correct? R1 and RP, they are in series. So the total, so now these are the only resistances left. So whatever resistance value we get, that would be the total resistance value. So I'll write here R total. Resistance would be, this one was R1 and RP. So it is R1 plus RP. What was R1? 7 ohm, and RP was 5 ohms. Correct? 7 ohms and 5 ohms. So what is the total resistance value? 12 ohms. So R total is 12 ohms. Correct? So for this combination, it is 12 ohms. So I can write this another equivalent circuit. So again, battery as it is, and here we have just one resistance value. This R total. This is 24 volts. 24 volts. And R total is how much? R total is 12 ohms. 12 ohms. Okay, so now what they have asked, total resistance. So we got the answer for total resistance, which is 12 ohms. So now find the total current in the circuit. So you look at this diagram. I'll redraw it if you want. The total voltage is 24 volt. Is it correct? 24 volt. And the total resistance value is 12 ohms. There is a total resistance value. Now we can use the Ohm's law. So current total will be voltage total divided by resistance total. Total resistance and there is a total voltage. So that will be 24 volt divided by 12 ohms. So that will come out to be 24 divided by 12 is 2 amperes. So the total current in the circuit is 2 amperes. So yeah, we have calculated this. Total current is 2 amperes. So if you solve it in step by step, you will get all the full marks. Easy? Now feeling confident little bit? Okay, we'll solve one more question. That is also previous year question. This was I think 1 or 2 years back, and this was for 5 marks. So now what is there? Why it is for 5 marks? You look at this diagram. There is an ammeter here. It measures the current to be 2 amperes. Then there is a battery which is 30 volts. So now this one is 6 ohm, this one is 6 ohms. This one 5, 10 and R1. So what you have to do is find the value of R1. So if you can find the value of R1, you will get 5 marks. But where to start? How will you start solving this? Looks complicated? Okay, I'll give you one hint. You look at this. I'll put this point as A1, A2, A3 and these 3 points as B1, B2 and B3. So now there is no resistance between A1 and A2. No resistance, no battery. That means no potential difference between A1 and A2. If they are joined only by the connecting wire, that means zero potential difference. Between A2 and A3, again no potential difference. So A1, A2, A3 all at same potential. So all of them at same potential. Correct? How are these 3? B1 and B2 connected by the straight, just by the simple wire. So zero resistance and zero potential drop. Again B2 and B3, there is no battery, no resistance. That means all 3 of them are at a same potential. So these 3 are at same potential. That means the potential difference between these B points and A point, the potential difference between A1 and B2 should be equal to potential difference between A2 and B2 should be equal to A3 and B3. So how will you redraw this structure? So let's redraw the diagram as, we keep as it is. Instead of ammeter, I'll just write the current which is 2 amperes. So here we have the battery is downwards and it is 30 volts. So the current will start from the positive terminal. So there is a current which is 2 ampere. There is the same current 2 ampere. Okay, it starts from the positive terminal of the battery. So now there is 6 ohm and 6 ohm. I'll write as it is 6 ohms and this one 6 ohms. And all these 3, they are in parallel because same potential difference between A1 and A2, same potential difference between A2 and B2, same between A3 and B3. So I'll just write 2 points here. This is point A and this is point B. So there are 3 resistances which are in parallel. And what are these? 5, 10 and R1. This is 5, this is 10, this is R1. Now looks better. Now you can solve it, but still it is little confusing. How will you get the R1 from this diagram? Still confusing, correct? So I'll take 2 more points. You see here the total voltage is 30 and total current is 2 ampere. So in the previous question we calculated the total resistance and total current. Here the total current and total voltage is already given. So what is the total resistance for this combination? R total. Can we calculate this? Yes, we can calculate using the Ohm's law. So this diagram I can write it in a simpler form, something like this. The battery is, and there is a total resistance, correct? And how much is the battery? 30 volts, current is 2 ampere. Sorry, battery is 30 volts, current is 2 ampere. So we can use the Ohm's law here, and using the Ohm's law, R total would be equal to V total divided by current total. So what is the total voltage? 30 volts divided by total current, which is 2 amperes. So the total resistance value would be 30 divided by 2, which is 15 ohms. So for 6, this 6, and let's call it as RP. So I'll redraw this. There is a 6 ohms. This here is RP, and this here is, this we have here 6 ohm. For these 3, the total resistance comes out to be 15, correct? But these 3, they look in series, correct? If let's say the current, if the current of 2 ampere is passing through, okay, I'll show you here. If the current of 2 ampere is passing through this, the same current will pass through this parallel combination. You see here the 2 ampere current, again 2 ampere current, again 2 ampere current. It will split here. But if I assume this as a single resistance, which is our RP, this RP, which is the equivalent of these 3, and again the same current 2 ampere flowing through it. That means this 6 and RP, they are in series, and the total resistance is given as 15. So let's write down. So R total is 6 plus 6 plus RP. And what is the total resistance? 15. So 15 is equal to 12 plus RP. So what is RP value? RP will be 15 minus 12, which is 3 ohms. This is the RP value. This is not the final value. But what is RP? 5, 10 and R1, they are in parallel. So I'll redraw it. This RP, which is equivalent to, there are 3 resistances here. Sorry, this doesn't look like resistance. Okay, so here we have the values 5, 10 and R1. So this is 5, this is 10 and this is R1. So this RP, which is the equivalent resistance, this is a symbol for equivalent. Okay, So now we can use a formula which is 1 by Rp should be equal to 1 by 5 plus 1 by 10 plus 1 by R1. But what is Rp? Rp is given as 3. So you can take these two terms to other side, or you can take R1 to other side, write the equation 1 by R1. I'll just write 1 by Rp minus 1 by 5 plus 1 by 10. Just rearrange the terms. So now substitute Rp value. So 1 by R1 is given as, what is Rp? 3 ohms. So 1 by 3 minus 1 by 5 minus 1 by 10. Minus 1 by 5 minus 1 by 10. So for 3, 5 and 10, what is the LCM? LCM would be 3, 0. 30, correct? So you have to multiply by 10. 10 into 3 is like 10 into 3 is 30 minus 5 into 6 minus 10 into 3. Correct? So 10 minus 6, which is 4, 4 minus 3, which is 1. So this will be 1 by 30. But what is this 1 by 1 by R1 is 1 by 30. So what is R1 value? R1 will be equal to 30 ohms. So this is our final value. So we want to calculate value of R1, and that came out to be 30 ohms. Awesome. Yeah, if you can solve it, try to understand. I'll tell you the trick how to solve this. When you look at this complicated diagram, understand which resistances are in series, which are in parallel, and how will you tell if there is a same potential difference. So they will be in parallel. If the same current is flowing through it, for example here same current is flowing through it, that means they are in series. Same current, they are in series. Same potential difference, they are in parallel. If you can understand this fact, then you can solve all the values, get all the values. And this is easy 4 mark or 5 mark type questions. So be very careful while solving these questions, very easy to solve. Alright, so that's it for today. You'll get the notes and assignment on this Telegram channel. Thank you so much everyone. Thank you for joining. Thank you for listening. Bye bye. Take care. If you didn't understand, pause the video, rewatch it again. You will understand. Alright, bye bye. Take care. Yes, I'm not able to see your name. Manura. Yes, you are first. Congrats. Awesome everyone. Bye bye. Take care. See you all.